Hey everyone, welcome back. Today we're going to be talking about sine, cosine, and tangent, and we're going to be looking at problems that are a little bit more complicated than that introductory video we made to trigonometry. So let's go ahead and let's get started. So one important thing to know about sine, cosine, and tangent is that the sine of any angle is going to be the same for all these triangles that we're looking at, okay? So it doesn't matter the size of your triangle. If I have a very big triangle or a very small triangle, and if I take the sine, and they both have a 30-degree angle, if I take the sine of the big triangle's 30-degree angle, and the sine of the small triangle's 30-degree angle, I will get the same exact ratio. Okay, trigonometric ratios are the same for all triangles. What that means is that the sine of any angle, okay, the sine of a 30-degree angle is going to be the same for all triangles if they have a 30-degree angle. Okay, so we use this to our advantage because the most common angles that we're usually working with are 45, 30, and 60 when it comes to sine, cosine, and tangent. There are angles that have to do with multiples of these three angles. Okay, so what we do is we look at what are the sines of these angles, the cosines of the angles, and the tangents of these angles, and we actually use them to help us find the measurements of another triangle, okay? And lucky for us, we actually know two special right triangles that have these three angles. Here on the left, we have the 45, 90-degree triangle, and on the right-hand side, we have the 30, 60, 90 triangle. We find the sine, cosine, and tangent of the 45, the 30, and the 60-degree angles by using these two triangles. And this allows us to be able to solve for missing sides of other triangles. So we're going to go ahead and take a look at how we do that right now. So you might not understand why I need these values, so let's go ahead and jump into a problem where I would actually need to use them. Okay, let's say I'm given this problem, triangle FGH, and they want me to find the value of y. Okay, I can do so by using sine, cosine, and tangent. Okay, it's a 30, 60, 90 triangle. I know that this bottom side of the triangle has the length of 9. So what I'm going to do is I'm going to go ahead and focus on this 30-degree angle. And I realize that, hey, if I do the cosine of this angle, the cosine of 30 degrees, and remember, SOHCAHTOA, the cosine is adjacent over hypotenuse. I actually have those two sides. I have the adjacent and I have the hypotenuse, which is why I went ahead and chose cosine. Cosine involves the adjacent side and the hypotenuse, okay, which are the two sides that I'm given. If I would have done the sine of 30 degrees, I would have been asked to use the opposite over the hypotenuse, which I don't know what the opposite side is for this angle, okay? So let's go ahead and let's stick with cosine of this 30-degree angle, and that'll get us 9 over y. And now, here's where I'm going to use those values that I showed you at first, because now I'm going to go back and look to see what is the cosine of 30 actually equal. Well, if I go up here, the cosine of 30 is the square root of 3 divided by 2. So I'm going to substitute the cosine of 30 that I have for the square root of 3 divided by 2. I know that the cosine of 30 is equal to the square root of 3 divided by 2, and that must equal 9 divided by y. And now it's simply a matter of solving for y. So first thing we're going to do is we're going to get y outside from being under the denominator. I'm going to multiply both sides by y. These y's will cancel out. I'm left with the square root of 3 over 2y. That's just going to equal 9. Now we want to get rid of the square root of 3 over 2 on the left side. We're going to isolate y. So we're going to multiply by 2 over the square root of 3. 2's will cancel, 3's will cancel. Beautiful. But now I need to do that to the opposite side. 2 over the square root of 3. I end up getting y equals 18 over the square root of 3. Now, normally you would have to simplify this, so let's go ahead and let's do that as well. In order to simplify a radical or square root, whatever you call it, we're going to do a multiply by 1 in the form of square root of 3 over square root of 3. Okay, what happens here is on the top we get 18 square root of 3, and on the bottom we just get 3. 18 divided by 3, however, is 6, so our answer is 6 square root 3. And you can type this into a calculator, figure it out that way as well. But this is how we use the values of cosine, sine, and tangent of these very common angles to help us solve for these types of problems, okay, where a side's missing. Let's go ahead and let's look at one more example. Okay, and one thing to note about this is that you can actually use, it's up to you as to whether or not you want to use sine, cosine, or tangent. Usually there's at least 2 you can use, all right? So for example, I could look at this 45-degree angle M, and now in this case, based off of this angle, what I have given to me from this problem, okay, is the opposite side, which is Z, and the hypotenuse. Opposite and the hypotenuse. So I could definitely use the sine of this as they gave me the opposite and the hypotenuse, okay? So I could do the sine of 45 and work this problem out. I could have also went ahead and gone with the cosine of this angle up here by L, because then I would have used adjacent over hypotenuse. But now let's go ahead and let's see, what does the sine of 45 actually equal? So again, going back to that same diagram, now I'm looking for the sine of 45, which is here, as 2, the square root of 2 divided by 2. Okay, so we're going to go ahead and substitute that in. So I know that the sine of 45 is just equal to the square root of 2 divided by 2. So now I can use this, okay, because now to isolate Z, all I have to do is multiply by 24 on both sides. 24 and the 2, those cancel out, or simplifies to 12. So really, 12 square root 2 is my Z value. So hopefully now you feel comfortable with using the values from a 30, 60, 90 triangle and a 45, 45, 90 triangle in order to help us solve for missing sides of different triangles, okay? Again, any triangle that has a 45-degree angle, that has a 30-degree angle, or 60-degree angle, we can go back and use these sine, cosine, and tangent values in order to help us solve for one of the missing sides. As always, I just want to thank you for watching, and I hope you learned some math. I'll see you guys next time.